Hello everyone, I hope you're all doing well. In this video, we'll solve this problem and it is related to band theory of semiconductors from solid state physics, and this is a requested video. The similar problem has been solved previously, but the language of instruction in that video was Urdu or Hindi, and there were a few of the comments that I got from the students who couldn't understand that language, so I'm doing it in English. So I highly encourage those students who couldn't understand my videos because of the language barriers, so you can simply comment about your issue and I'll respond to it as soon as possible. Now let's see what the problem is. It says that what is the probability that energy level 3 kT above Fermi level is occupied. Okay, so let's say this is the Fermi level. Okay, and they are saying energy level which is 3 kT above Fermi level. It means that there is some energy level above Fermi level which would be like this. Okay, and the difference between these two levels is 3 kT. As this says, keeping in view the Fermi level as a reference level, they say a level which is 3 kT above the Fermi level. So that's actually the difference between that level and the Fermi level. Okay, so you can say that E minus EF is 3 kT, because 3 kT, as you can see here, it's relative to the Fermi level. So it's actually the difference of that actual level and the Fermi level, 3 kT. Whenever, as they are saying it relative to the Fermi level, that is why you have to write it like that. Okay, so this is something that we are given with, and we have to find out the probability that this state is occupied. And the probability that a state is occupied is given by the Fermi-Dirac probability distribution function, which is f of E. This is the probability of occupancy of a state by an electron. Okay, and it is given by 1 over 1 plus e to the power E minus EF by kT. And now we will put the values here. E minus EF is 3 kT over kT, and kT gets cancelled out, and we are left with e to the power 3. Okay, 1 over 1 plus e to the power 3, and if we calculate it using a calculator, then we will get 0.0474 as the probability that a state 3 kT above Fermi level is occupied. Okay, so whenever you have to find out the probability that a state is occupied, you have to use this formula. If they are saying that find out the probability that energy level is occupied, and this is normally considered for electrons. Okay, and if they want you to find out the probability that a state is occupied by a hole, so you have to find out 1 minus f of E, because hole is the absence of electron, and whenever they want you to find out the probability for hole, they will properly mention it. Otherwise, if they are not mentioning it, you have to understand it by yourself that they are saying to find out the probability for state to be occupied by an electron. Okay, if they are saying what is the probability that the state is empty or the state is occupied by a hole, then this is something that you have to do. This is the probability that a state is occupied by an hole or empty of electron. Okay, where f of E is the probability of occupancy, you have to simply subtract the probability of occupancy from 1. And for example, if you want to find out what is the probability that the energy level 3 kT above Fermi level is empty, then what you have to do is find out the f of E, which is this, and subtract it from 1. You will get the probability of the state being empty. Okay, and if you want to find out the percentage probability, then you have to simply multiply this probability with 100, and you will get the percentage probability. For example, percentage probability that the state is occupied is 0.0474 multiplied by 100, and you will get 4.74%. Okay, this is the probability that the state will be occupied in terms of percentage. I hope you got it now, and like, share and subscribe. Goodbye.